This is Narmada Naveen Sundar. Today we will see about the next important data structure that is called as linked list. So in the previous session we have seen about the array data structure. So before we move on to the linked list, we should know what is the difference between the array and the linked list data structure. So what do you mean by that array data structure is? So array is a collection of homogeneous elements which will be stored contiguously in the memory location. So imagine how the books would be arranged in the shelf. So each book will be in contact with the next book that is stored in the shelf. In the same way, the data elements will be stored contiguously in the memory location. So but the linked list, it is just the collection of homogeneous elements, so which will not be stored in contiguous memory location. So wherever there is a space, data will be actually stored in the available space. And these memory locations are generally called as nodes. So as you have learnt in your theory class, so every node, it carries two parts. So the first part is a data part, which holds the actual data elements, and the second part, it is called as the link part or the address part, which holds the address of the next node in the list. So in this diagram, so this represents the typical structure of a node in the list. Now we will see about the properties of the linked list. So when we take the properties of the linked list can only be accessed sequentially. But when we take the array elements, so we have indices. With the help of the index, we'll be able to perform both sequential and random acts in the linked list. So here in this diagram, so if you watch the diagram closely, we have some list of elements. So here we see that there is a first node with the value 1 and then 2, 5 and 3. So the first node is addressed by a special type of node that is called as head node. So this head node, it actually stores the address of the first element. The first element in turn, it holds the address of the second element. Second element, it holds the address of the third element. Third, it holds the address of the last element. And if you watch the diagram closely, so here we have a null value. So the link part of the last node, it holds a null value to denote that is the end of the list. So this is a typical properties of linked list. Now we will focus on the operations of the linked list. So what are the operations that could be done with the help of the linked list is, so as we have learned in the theory class, we'll be able to perform the insertion of a node in the beginning of the list, and we will be able to perform insertion of a node in the end of the list, and we will be able to perform the insertion of a node in the middle of the list. In the same way, when we perform the deletion of an element from the list, so here also we have three scenarios. So how do we do the deletion of a node from the beginning of the list, and how do we do the deletion of a node from the end of the list, and how we can perform the deletion from the middle of the list. And the third important operation is traversal of the elements. So what do you mean by this traversal is, so right from the first node till the last node, we need to visit all the nodes in the list. So these are some of the operations of linked list. And then, so now let us take different examples to explore how the insertion is done in the beginning, in the end and in the middle. So as the case with the deletion. So let us consider, for example, this is a list of nodes. So I have some set of values 13, 25, 55, 32, which is the last node. Let us consider, for example, I just want to add a new node with the data value 35. So here's this new node, it has to be created, it has to be added before 13. So now the address of 13 is currently being stored in the head node. So what I could do is, the first and the foremost thing is, I need to create a new node with some data in it. So in this diagram we see that a new node is created with the data value 35. And what is the second step is I need to first update the link part or the address part of the newly created node with the address which is actually stored in the head node, because head, it currently holds the address of 13. So the address of 13 has to be now stored in the newly created node. And the next step is I need to update the address part, that is the link value of the head node must be pointing to the newly created node. So here this is how a new node has been added in the beginning of the list. So here we see that this is how our list will be once the insertion is done in the beginning of the list. So let us consider the second example. How can we do the insertion of an element at the end of the list? Say for example, I just want to insert a new node at the end with some data 35 in it. So what is the first thing I have to do? Yes, exactly. So before I do the insertion, I need to create a new node with some data in it. And then what is the next step is I need to update the link value of the newly created node with the link value of the previous last node. So the previous last node, it carries a null value because that was the previous last node. So now 35 becomes the new last node, so that the address part of the new last node must be updated with a null value. Then what else has to be done? Then the address point, so now 32 must point to 35. So what I could do is I need to update the address part of the previous last node to point to 35. So now we have seen that 35 becomes the last node in the list. So this is how our list will be once an insertion is done in the end of the list. The next operation is how do we do the insertion in the middle of the list. Say for example, I just want to insert a node between 25 and 35. How this could be done? Yes, initially I need to create a new node with some data in it. So 35 is the new node which is created. So now how I could add this new node in between two other nodes? The first thing is I need to update the address part of the newly created node with the address of 55. And then 25, the node with the value 25 must be updated with the address of the newly created node. So this is how I'll be able to add a new element between two other elements. So here we have updated the link value of the newly created node, so with the address of 55. So where is the address of 55 is currently being stored? It is stored here. So whatever is there in this particular node must be copied here, and then the address part of 25 must be pointed to 35. So now a node has been added in between the first and the last node. So this is how our list will be, how an insertion is done in the middle of the list. And then the next important operation is how do we do the deletion of an element from the beginning, from the end, and from the middle of the list. So let us consider for example. So there is some list of elements. The first node, it carries a data 13. So this is the node that has to be removed from the list. So how I could remove the node? So currently, if at all I need to delete the node, so initially I need to begin the list with the head node, because head only carries the address of 13. So only if I reach the head node, I'll be able to find where the first node is actually stored. So what I could do is I need to store the address of the current head node to some temporary variable. And how I could delete the current first node is I need to make head node to point to 25. So first store the address of the head node to some temporary variable, make head node to point to 25, and then remove 13 from the list. So this is how the element is removed from the beginning of the list. And since that element is removed, 25 becomes the first node. So this is how our list would be after we do the deletion from the start of the list. And then how do we do the deletion from the end of the list is, so imagine I have some set of elements. I need to delete the last node from the list. So what I need to do is I need to make the previous node of the last node to point to null, and before that you store the address of the last node into some temporary variable and then delete the node. So let us consider 35 is a node that has to be removed. So what we need to do is update the previous node. So 55 must be updated with a null value, because once 35 is removed from the list, 55 will become the last node in the list. So this becomes the last node. So this is how our list will be once we delete an element from the last of the list. And then how do we do the deletion from the middle of the list? Say for example, I need to delete the node with the data 55. So how I can identify where the data is actually stored? So right from the head node, I need to traverse to the first node, from first to the second node, which is actually 25, because 25 carries the address of 55. So what I could do is, so once I got the address of node 55, store the address of 55 into some temporary variable, because we are going to remove the node from the list, and update the link value to point to the last node. So once we update the address of this particular node with the address of 35, we will be able to easily remove the node from the list. So no other modification will be done in the first and the last. So this is how our list will be once we do the deletion from the middle position. So whenever we perform the insertion, or whenever we perform the deletion in the middle of the list, so we need to be very cautious to traverse the list from the beginning, because the elements are stored in a sequential, so elements could be accessed through the sequential manner. So from the head to the first to the second to the third, and we need to traverse till we reach the end of the list. So now we will conclude with what is the comparison between the array and the linked list. So in which scenarios we need to use an array data structure, and which scenarios we need to use the linked list. So an array data structure could be used when you are sure about your requirement. Say for example, I have the details of the 5 students to be stored. In such scenarios, when your requirement is exactly very well known before, you could use an array data structure. But in the case of the linked list, when your requirement seems to be very dynamic, you're not sure about what will be the number of students who will be enrolling for a course. In such scenarios, a linked list will be useful. An array will not be useful when the insertion and the deletion operation is going to be very frequently done. So in the theory classes we have seen, whenever we are going to do some insertion of a data in between two other elements, so we need to check whether there is any sufficient space in the array, and we need to shift all the elements, and in that particular index position we need to copy the data. So as the case with the deletion, so that the complexity increases when we do the insertion and the deletion. So here we can easily use the position to perform the insertion and deletion, which will be always easy. And array, as I said in the beginning of the lecture, we will be able to perform both sequential and random access. But in the case of the linked list, we will be able to perform only the sequential access. So far in this lecture, we have seen about, so what do you mean by the linked list, the comparison between the array and the linked list, data structure, and we have seen about what are the important properties of linked list and what are the operations that could be done with the help of the linked list. So thank you for watching.